Didn't did it? Half did it, doubly written. Okay. Okay, fine. Those who did it, it's fine. Those who didn't did it. Just try to finish it this weekend. We'll start our session today. And Kishan, sorry, I didn't got a chance to see your code. And did you modify your Magic Square code and found out whether it was working or not? No, I didn't. Okay, fine. Okay, great. If you are like, if you'll see it and if it start working, just tell me. And even if it's not working, then also like just message that that this particular approach is not working. Okay. Okay, then we'll proceed further.
I have a small question. Previous one. Can you move left side?
Yes, Sai, do you have the doubt?
Yeah.
Yes.
See here we need to return node, right? RTH.
For the singly linked list you're talking about?
Yeah.
Yeah.
Last line. So node, right?
Yeah, right.
That's it.
That's it. Okay.
Yeah.
Okay, so our next question for the day is, you have been given a linked list and you need to find out what is the size of that linked list. Okay. Let me just write that question. Or more simpler question than that, you have been given a linked list and you need to print all its element. That is, printing means its return type should be like, doesn't matter. So void and print. Then I'll be giving you the head node of the given linked list and you need to traverse the linked list and print all its elements. Clear? Okay. So does anyone has any idea how to print the elements of the linked list? Okay, okay. So I'll just give you an example over here. Let's suppose your numbers are 3, 5, 1, 6, and 8. These are the link. This is your linked list. This is your head, and you need to traverse, and this is your null. If you want to print every element, you should visit every element at least once. And for visiting every element at least once, you should traverse. Until when we should traverse in the linked list and where we should stop? Kishan, I've seen your statement. No need to re-message it again. Yeah, correct, Vishnu. So it should stop when we are reaching null. So until we have not reached null, you can simply write that while your head or h is not equals to null, in that case, what you need to do, you simply print your head.data. And what you need to do next, you have printed this particular element. Now you need to move to next, right? And for that, you should change the value of your head to head.next. Clear?
No.
Yes.
Ma'am, I think head contains the data and it contains the address of another node, right?
Correct. Yeah. Yeah, you are
Then,
right.
yeah.
No, Vishnu, why to print head after that? We have printed every data of our linked list, right? There is no need to return anything here.
So if I understand this, like it will go until 6 because
It will
uh,
go until 8.
but 8 is pointing to null.
8 is pointing to null, but 8 is not null itself. Read our condition again. While head is not equals to null.
Yeah, so the we are checking in while loop, head is not equal to null. We are not checking for the data.
Right? We are not bothered about the data at all.
Okay.
See,
Okay. Got it. Yeah.
until the time you are getting the next addresses that indicate that there should be some data inside that specific node. Right? Because if a node is being made, there should be some data inside it. That's an obvious case, right?
Yeah. Yeah.
So keep that thing in mind. We are never bothered about data in terms of linked list and all.
Got it.
Ma'am,
Clear? Yes.
ma'am, each contains the data as well as the address of another node, right?
The node contains the data and the address of the another node, right? Aman, are
Then,
you asked?
yeah,
Yeah.
yes, ma'am. Then each denotes data as well as nodes, as well as the address of another node.
See, I'll make a diagram for you to understand. Your head looks something like this. One portion is the data, one portion is the address of
Address.
next address node. Okay, so here let's suppose the address of this particular node is 1010, and your next node address is, let's suppose, 2020. So this address will be stored over here, 2020, and your data, let's suppose, was 3. So since it knows the address of this specific node, hence it is pointing to it. Clear?
Yes, ma'am. Yeah, then my question is H denotes the data as well as the address.
Yeah.
That's why we have written the condition H is not equal to null.
Yeah. When we have written H is not equals to null, we are only concerned about address. Okay. Always understand when I'm mentioning to you node H or like H is some value of the node. Okay. And it can never be some number, some string or anything. It can be some kind of like mixed string or something else. Like we can never define what actually H is. So whenever it comes to the point that whether you have the next node or not,
Okay.
just give me a minute. So when it comes the point when you don't have any next node, at that point we say it's equals to null. Clear?
Yes, ma'am.
Any further doubt?
Mm.
Bhuvnesh, I will track this code and will let you know that.
Ma'am, you have written H equal to H dot next. It
Yeah,
means
right.
it will check the another node, right?
It means that it is moving its pointer. Like let's suppose you have to like someone is saying that you have to cross 5 houses, then you will reach your destination or you will get you can say your reward. Okay, so what will you do? You are a single person, right?
Yes, ma'am.
And if you have to cross 5 houses, let's suppose you are using their rooftop, so what will you do? You will just jump from one roof to another, right?
Yes.
Yeah, that's what head is doing. Head task is given here, like you have only single head, right?
Hmm.
You are already on this particular terrace, like terrace of this house.
Yes, ma'am.
Yes, no. Now you have to traverse the other 4 houses as well for the reward. Like let's suppose your reward is here. Okay, so what will you do? You will jump from here to here, right?
Yes, ma'am.
Jumping is equals to this H equals to H dot next. When you jumped here, okay, you find out that this is the data, you printed it. Now your work is done in this house.
Hmm.
Then you will make again another jump. So this H equals to H dot next is nothing but we are jumping from one node to another node.
Okay, then H denotes the address or the data.
H denotes the address. It's never like it is a combination of the address and the data. So when you will try to get H dot next value, it will give you the address. When you will try to find out like this H dot, what should I say, data, it will give you some integer value. And if you only talk about H, it will give you some address of the node where it is located in the memory.
Okay, ma'am.
Clear?
Yes,
Where
ma'am.
it is located in the memory. Clear?
Yes, ma'am.
Any other doubts further? Like if you have any doubts more, you can just ask it without any hesitation.
Yes, ma'am.
Located in the memory. And talking about the extra print statement, Bhuvnesh, see here, like I'm just traversing right now. So it initially checked for this 3 if it is equals to null or not. It will be false. Like here it will be true, H is not equals to null, true. It will come in and print 3. It will work, right? Yeah. Similar to this, now we have another question which is of size. You have been given the node or the head node of your linked list and you need to figure out what's the size of the linked list. It's very similar to the previous question, just you have to return the size and yeah, you all have to tell me how you can do that. Correct. Most of you figured out like what we need to do. So I'll just simply write the code over here. So here I'll take int size, okay, which is initially we don't know that I'll take it as 0. Again, the same thing because you need to traverse on the entire linked list to know its size, right? So while h is not equals to null, those who are not able to get anything out of this, just no need to worry about it. Just give me a minute, guys. So here you will just traverse and see if h is not equals to null. If it is not equals to null, in that case, just do size plus equals to and 1 because now you know that there is at least one node which is not equals to null. Next time, next thing what you need to do, you have counted this node. Now you need to see if the coming or the next node is also not equals to null or not. So you will pass h dot next as your head and then it will keep the count running. Everyone, are you clear with this or have the questions 2 yes. What about the remaining? Yeah, I forgot one thing. I forgot to return the size. Yeah, and that's it. Clear to all? Anyone in the class who is there, like whose concept is still not clear in both the cases, the printing of the linked list and the size?
Ma'am, one thing I was thinking that in the constructor of the that node, we can have one static or global variable length, and then while the object is getting created, we'll keep incrementing.
Where will you have that global variable?
Oh, so it will be outside the node class,
Then
and
obviously it will be inside the class where you are, where let's suppose you are using your linked list functions, right?
yeah.
Yeah, so like it will be a thing which you need to do repeatedly for all the functions if you're writing for the linked list, right?
No, actually, what my
Okay.
thinking is that how we do in array list, we have some way by which we could just check in the constructor itself that this has incremented instead of creating a new method of size.
Okay, can you tell me how we do it in the array list?
Uh, no, just like array dot length. When we put, then we just get the exact length. I'm not sure array or array length, but my whole idea is in the
See,
constructor itself, we can keep on incrementing a count.
first of all, array list is a predefined library. Okay,
Correct.
so it has some predefined functions, and length is one of it. Next thing, linked list is also a predefined library, and it has also a size function. So you need not bother about creating another length function. First thing. Next thing, we are right now learning the internals of linked list. That is, how can a node be created, how we can traverse on those nodes, and like, yeah, what are the things to be done? Because if you see the implementation of the linked list in Java, it's way too simple. You just use the methods and the things will be done. So right now we are not doing that. We are learning the linked list from the base.
Oh,
Clear?
yeah.
So yeah, you can still do that length function, but it is already implemented. Like you need not do it. And if you want to do it, it's very simple. Whenever you are writing some code for the linked list as a global variable, you can initialize some length. And every time you are creating the node, just increase that length. So your concept is perfectly right. You can use that.
Thank you.
Okay. Yeah. So we'll move to our next code, and that is that you need to insert some node. No, before that, let's discuss this. You need to print your linked list in a reverse order. So since it is a printing thing, void return type should be there. Then it should be print reverse, and you will be given the node h. Okay, so that means if I have given you the linked list as, let's suppose 3, 6, -1, 8, and 2, then you need to print it as 2, 8, -1, 6, and 3. Clear, everyone? Let me just write its output. That is 2, 8, -1, 6, and 3. Okay, so now can anyone help me with it and tell me how can you print the linked list in a reverse fashion? Think about it for a minute or two and then tell me. As we traverse to null, store in an array and print. I don't want to use any extra space. Again, one more constraint. Think of the concept, all the concepts that we have learned recently. Put in stack. Okay, now Vishnu, instead of creating a stack on our own, can you think of something that we don't need to create a stack on our own and our work is also done? Like using the stack itself, but we should not create it. It should be done by our system. Can you think of that way? Guys, you have learned recursion recently. Okay, and you should know that when you want to print array in a like reverse manner or anything, we saw how to use recursion in that sense, right? Anyone remember? Here it will be just like we need to just assume that this print reverse function is gonna print our linked list in the reverse manner, and you just need to pass here h dot next, like always the next element. And once you know that, okay, all the elements are being reversed, actually start printing it. So print, and here you can print your head dot data. Clear? And you should stop your this traversal when you know that your head is equal null. At that point, you just need to return. Yes, now any one of you remembered that we are using this tag, but it is not being created by us. It is the tag which is given by the recursion to us. Others, what about you? I can only see 2 to 3 people responding all the time. Remaining, what are you doing?
Ma'am, one doubt I have is that when we are reaching this print statement, the last statement of this function, then there is no recursion. So it will just print single time.
See how the things are happening. If you understood recursion, then you should not be asking this question. Okay, so this printer function will come. It will check if your head like h is equal null. Obviously, right now it's not. It will go here. That means it is recursively calling this function again. So initially you called this function with the head value as 3. When you again called it, now your head value has become h dot next, that has it become 6. Next time when it will you make the call, it will become -1. Aman, you can see this demonstration, and after that, if you are confused, you can tell me your confusion. Then here 8, and then the last time when you will make the call, it will be for 3, sorry, 2. When all the calls are done and still it will reach this particular print R statement, after this, like h dot next, that time it will become null and it will return. Are you getting this? When it has become null, it will return. Vishnu, are you getting this up to now? Okay.
Yes,
In
madam.
this particular recursive stack, what is being done? Up to here, your X statements are being executed, but this is still remaining h dot data, right? So you need to print this h dot data now. So your h dot data was 2, so 2 will be printed now. Once this is printed, your function calling is being done. Now this recursive stack will be destroyed and it will move on to execute the previous recursive stack. Here also, up to this limit, the function was executed. It has to print the data. So it will print 8 and it will destroy this recursive stack. Same thing goes with the remaining numbers, just in the reverse order. So -1 will be printed. This will be destroyed and 6 will be printed. This will be destroyed, like 3 will be printed and then it will be destroyed. Clear?
Yeah, it isn't very clear now.
And yes, Aman, are you still in the doubt?
Ma'am, I am confused in we are passing argument as node H.
Yeah.
I am confused in that part.
Like, what is the confusion? That's my question.
What are we passing in that function?
Print reverse function?
No, ma'am. Yeah, print or node H, the first line.
We are not passing, it's the function definition line, right? It is receiving this head node. You always, whenever there is a linked list, okay, how
Yes,
do you know how long your linked list is, where it is located? Always for that purpose, you are being given the head node. That means the address of your this node is being given to you, so that you know that this is the point from where your linked list is getting started.
ma'am.
Clear?
Yes, ma'am.
So when you know the starting node of your linked list, you can easily traverse till the last, right? But when you don't know the starting point, how can you reach the ending point? Clear or not?
Yes, ma'am. Yes, ma'am.
And if you're not clear, just tell me your doubts exactly, okay? Like this thing should be clarified in the start itself, okay, Aman?
Yes, ma'am.
Our next function is, you have been given an insert function. With the insert, you must have understood that we need to insert some node. So for that, again, every time in every question of the linked list, head node is a necessary thing. Because from that, like you all know, whenever we talk about array, you have been given the array, right? Yes or no? Similarly, whenever we talk about the linked list, head node should be given. Clear? Next is, you will be given the X number which you need to insert. And the next thing, you will be given the position where you need to insert the number. Clear? Okay. So that's it. You have the position, you have the number, you have the head node. How can you insert it? Any ideas?
Yeah, so X is the index.
X is the
And
number.
so I'm thinking, what's the difference between X and position? We
Position is
have,
the indexing. Position is the index where you need to insert your number, and X is the number itself.
total number of elements in the node, in
No,
the linked list.
no. Inside every node, you have some number, right? The
Oh, got
data.
data. Yeah, yeah, yeah.
Correct.
Okay. So I was thinking that if it is in the middle, then we have to assign the address of this input node to
Again, for
the
looked at.
to the
Good.
previous node.
Which previous node?
And so, I mean, I'm just thinking that first of all, we have to traverse till that position. Then at that position, assign the address of the current node to the previous node, and then take that node's address and pass it to
Vishnu,
itself.
Vishnu, first of all, think once and then narrate it, okay? Are you clear with your concept, what you are gonna say?
Yeah, I mean, I'm just thinking it's like a chain. Break the chain and then insert it
Insert
in.
it, right. That's right. Just
Yeah, I'll type my.
no, I got it. But there is just one slight change that I want to make to your concept. You said that if you want to insert some new node, traverse to that position and then insert the new node, right? That's what you said, correct? And yeah, consider the indexing from 0. Yeah. So now let's suppose I want, this is 3 minus 1, 6, 2, and 4. Let's suppose I want to insert the number at third index and the number is 9. Okay. So if I will traverse up to here, then I cannot insert a number at 3 because I am already at 3. So the concept is you should traverse till position -1, that is here, then break this chain, insert your new number over here, and then point this new node to your previous node, and here is your data. This is the concept. Not till the position, it should be position -1. Other than that, your concept was right. Bhuvnesh as well as Vishnu, you both have said that till position, not till position, before, like one before the position. Okay. Like, can I expect you all to write the code for this? Because you should also do some brainstorming, right? Like why I should give you all the codes as a spoon feeding. Okay, 2 minutes writing. Okay, you can start on with the code. That will be great. Yeah, obviously every language support linked list. You can just search for it and you will find it's okay. I'll just paste the code which Bhuvnesh has given to me so that you all can have a reference to visit. Yes. Sorry, my bad. Okay, guys, you can see this code later. You have the whiteboard link, so you can go through that. Anyone needs any brief on this particular question? No. Okay, Kishan has also sent it. I've already pasted one code, it's fine. Next is our next question is again an insert function, but a slightly different version of it. So in this particular question, you have been, yeah, and why there is always the like return type is node. Can anyone tell me that? Like here also, the return type was, sorry, I guess here Bhuvnesh has mentioned it as void, but it should be node. Let me just specify that to you. And can anyone tell me why is that? And Kishan, is it correct? Your node, have you like your code, have you checked it? No. See, you are doing here that count is less than position. So it will keep going until your count is less than position. But once it is equal to position, it won't go. But I want to stop at position -1. So it should be position -1. Once this point is done, then it's fine. Then what you have done, head equals to node. And this if condition, after executing this if condition, okay, you have put the continue statement. Okay, got it. So, okay, it is clear. Then it at the end it will come assign h head equals to node. No, it's wrong. It should be like if your head is at position -1, then your head dot next should be node first thing, and your node dot next. And for that, now see, once you are breaking, just a minute. Understand this, you have these two nodes and there is a link between them. You are breaking this link. So you should store this link somewhere, right? That is the first thing you should do. So here you should store that in some temporary node. So I'll store it here as node temp equals to head dot next. Now I stored it. After that, I am assigning this head dot next to some other new node. So this got breaked. I am assigning this next to some new node. Okay. Now this new node should also be pointing to this previous head dot next, which I have stored in the temporary variable. For that reason, now you should write one more step here. That is your node dot next is equals to temp. These are the 3 line of code which you need to write to finish your code. Otherwise, that was wrong. And here what you have written now, that node dot next equals to head dot next. This is wrong. Clear? And at the end, you are saying that you are returning the head, but you should realize that you have already moved your head, right? So before moving your head, you should be storing it in some temporary variable. So node th equals to h. Next, the reason I am saying that its return type should be node is that what if someone asks you that, like, this is your linked list, okay, having the 5 numbers, and someone asks you that you need to insert the number on the 0th position. If someone asks you that, then you obviously you need to replace your current head with some other head, yes or no? And if that is the case, then your main function should also know that your head has been changed, and that's why we need to return the node. Is it clear to you, Bhuvnesh? Okay, and the same thing goes here. The next insert function that I'm going to explain over here. Just understand that in this specific question, your linked list will be sorted. Okay, you will be given the head node. Sorry, head node, and along with that, a number, int x. Okay, so whatever this number is, like, let's suppose your linked list contain the number as 3, 6, 10, 12, and let's suppose 20. I want to insert the number that is, let's suppose, 11. So 11 is bigger than 10 and it is smaller than 12. So this number should be inserted in between 10 and 12. Clear? You have to insert this number in such a way that your linked list stays sorted. Clear? Is the question clear? Okay, so now you need to figure it out how you are going to do that. That's your, again, a task. But before that, I'll just give you 2 to 3 more tasks so that if you guys want to do more questions on the linked list this weekend, you must be having some buffer. Anyone in the class who is not getting anything in the linked list? Or getting some, but still is like, the linked list of stuff? Anyone who is finding linked list stuff? That is the main question. Stuck in the basic concept? Aman, I am here for the discussion. The class is almost over. You can ask your doubt. Please go to the before question. Okay. This week, I am not giving you more questions on the linked list. Try to go through your recursion stuff this weekend, and yeah, we'll give you more questions the next week. Yes, Aman, are you gonna start asking your doubts?
Ma'am, I will revise all the sessions and I will ask if I
Like
stuck in.
any question in your mind which you want to ask right now, I am there.
Ma'am, I want some time actually. Currently, I don't know what should I ask.
Okay, sure. You can take your time. Okay, then. So we'll like stop the class right now, and I'll see you guys on Monday. Anyone wants the question further, I can give you still 2 or 3 more. And if you don't want to revise the concept on recursion, okay, I'll just quickly give few questions. One question is node, sorry. Now onwards, I won't be writing the return type. You figure it out on your own. Next function is delete. Need to figure out the return type. You will be given the node, like the head node, and you will be given the position from where you need to delete the node. Deletion is nothing but, if I'll tell you, let's suppose you have the nodes like this. The numbers are 3, 5, -1, 8, and 6. If I'm telling you, you need to delete the node at second index. Okay. It's simple. You need to unlink these and unlink this and create a link between these two numbers. This is what we call as the number is deleted, because when you're not able to reach the specific node, then obviously it is termed as a deleted node. Clear? Yes. So this is one question. Next is, you have been given again a sorted linked list with, you can say, the multiple occurrences of a same number. So the linked list, you can say, look like 1, 1, 3, 3, 7, 7, 8, 8. And I tell you the number, like let's suppose I'm giving the function definition as delete all, and I'm giving you the node head. And next is int x. This x is nothing but the number. Okay. So let's suppose I gave you the number 3, then you need to delete all the occurrences of 3. If I gave you the number 8, then you need to delete all the occurrences of 8. So hope you understood the question. Yes. Okay, so these 2 questions you can like figure it out on your own. If you're able to do it, well and good. Otherwise, I'll be discussing these in the class. I'm expecting that this should be done by you all. So yeah, I won't be explaining this in the class unless there is the majority of people saying that we are not able to do it. Okay then, so guys, happy weekend. I will see you all on Monday. Bye-bye.